Hello, this is Professor Gibson. This is part B for chapter 11.6, Math 115. So what's actually happening in here, all I'm going to do in part B is we're going to do some example problems straight out of Connect Math, all right? So let's start. For the area under the standard normal distribution curve to the left of minus 0.55. In other words, this is what's the probability you picked a value with a standard deviation, right? With a z-score less than negative 0.55, right? Now, you'll notice this little mark here. Now, you can't, in the way this is set up, I couldn't click on it, but you could when you're in Connect Math. I really don't recommend it. It's the same information that's in this table, okay? But it's organized differently, and I think it's harder to use. So there's my recommendation for that, okay? Goodness, I keep clicking that back up there. All right, so left of minus 0.55. All right, so what we're going to have here, our table, the table shows, if you look at the graph, look at the diagram, see it shows the area to the left of the z, and here we look up the z, the first two digits of it are down the column, the third digit is across the top. And this is the area here, this is the probability of being less than that z. So less than minus 0.55, the first page of the table has negative z's, the second page has positive. So negative 0.5, and we come over to 0.55 and get 0.2912. Okay, so that's the way the table works for that. And this is in a sense, this is the perfect question, since the table gives us the probability of being less than or to the left of when they ask us. So less than question, we just got to look up the number. Whoop, and it's not negative, it's positive. I'm not sure why I wrote the negative there. This is a probability, right? They're always positive. So let's look at the next one. I think that came down too far that time. Nope, okay. Find the area under the standard normal curve to the right of 1.05, right? To the right of z equals 1.05. So this is the probability you randomly pick a value whose z-score is bigger than 1.05, right? In other words, it's more than 1.05 standard deviations above the mean. Just like this one, it's to the left of that would be more than 0.55 standard deviations below, right? The negative means below. So above, so we're going to have to find the complement here. So first we look up in the table for a z of 1.05. The first page is the negative z. The second, I'm just going to scroll down. The second page is a positive. All right, so 1.05 it says, 1.0, and then over to the 5. Looks like 0.8531. 0.8531. Now remember, the table gives me the probability of being less than that, right? I want to be right. I want probability being more than that. So if 1 is the total probability, and that's 0.8531 is the probability of being less. So I want the probability of being more. I just do 1 minus that. Right? This is what we always do. We want a probability of being more than a number. Look up the probability of being less than that. Do 1 minus, and I get 0.1469. Okay, here's the next sort of standard kind. This is the third of the three standard types, if you will. What's the probability of being between two numbers? 0 and 1.85. Okay, so what we're going to do here, the probability of being between two numbers, is you find the probability of the bigger one first. All right, probability being less than the bigger one. So you want to think about it as a picture. I've got a number line here. First, I'm going to get the probability of being less than, I got 1.85 on here, right? So the table is going to give me the probability of being less than that all the way out to infinity. But what I really want is the probability of being between 1.85 and 0. We'll draw the same number line. 0. All right, so I look up the probability of being less than 0 in the table. Okay, and then I take this bigger area here, right? Subtract off this smaller area, and it leaves me the one I'm looking for, between 0 and 1.85, right? So we're going to get the probability for being less than 1.85. We're going to get the probability of being less than 0. We're going to subtract the smaller from the bigger. So 1.85 and 0, we'll go, yeah, we're in the positive table here. So 1.8 over to 8.5. There's 8.4, 8.5 is 9.678. 0, if you remember, 0 is in the middle, so it's going to be 0.5. But if you look it up, there's 0.00 is 0.500. Okay? So this ends up being 0.4678. It's a probability being between 0 and 1.85. All right, one more question I'm going to do here. And so this one has a little bit of a twist to it. Some of the homework problems have that. And ask us to work just a little bit harder on this, a little bit more. Okay? So assume the data set described is normally distributed with a given mean and the given standard deviation with n total values. So what's going to happen is they're going to say the mean's 100, standard deviation is 10. There's n values in this distribution. Find the approximate number of data values that will fall in the given range. So what we're going to do is we're going to find the probability of falling in the range, the probability, okay? And then we're going to multiply that times the number of data values. And that'll give us the probability of, how many data values we'd expect in that range. So first we're going to have to find our z-scores. This is the first time we've had to do it. I talked about that in the last video. So 80 comes first because it's smaller, so we'll call that z1, right? Remember, a z-score is the data value minus the mean divided by the standard deviation. So what we have here is we have 80. They tell us the mean is 100. Standard deviation is 10. You do that, it turns out to be minus 2. And then Z2 is going to be for the bigger one. This is 120. Again, right, it's x minus the mean. Always is over the standard deviation. So I'd recommend you write that out every time you do one of these questions. It'll help you memorize the formula. Anyway, so x is times 120. And then it's still the same question, so the mean is still 100. Standard deviation is still 10. This is positive 2. So now we want the probability of being between positive 2 and negative 2. This will work just like before, right? So we need the probability of being less than 2. Let's see, so we've got here 2.00 is 0.9772. Okay, 0.9772. Now we're going to do minus the probability of being less than minus 2, right? This is our other one right here. So to get minus 2, we got to go up to the previous table. And all right, so let's go through, we can see the headings. All right, so for the negatives, the order of the third is reversed. So minus 2.0 is all the way to the right. Last column, 0.0228. Okay, so we subtract those. And we get 0.9544. Now the question is, if we did stuff at random, how many of our picks would we expect to be between these two numbers? Well, the probability of being between these two numbers is 0.9544. So the number that we would expect to be between them is that probability times however many numbers there were or were picked, which in this case they told us the n, right? The n right here is 200. Okay, so this turns out to be 190.88. Okay, and then so you could round, right? If it was the whole number, it'd be 191, whatever. Okay, so there's a series of questions, calculations, if you will, straight out of Connect Math. I hope you found that helpful.